with AES 128 and 256, it is 350 to 1,000 times slower for cracking. So that means with an RC4, a password that I might crack in a day now takes 1 to 3 years. Which, to be honest, this is one of those situations where if you've ever heard the analogy for running from a bear, I don't have to outrun the bear, I just have to outrun the person next to me. How much time are the attackers going to spend? Are they going to spend a year, 3 years? Now, some organizations, government, who knows, maybe they will. I'm ready to rock and roll, yes.
Yeah, awesome, dude. Let's do it. Well, thank you everyone who's on. Appreciate you all joining. So guest today, Tim Medin, CEO of Red Siege, but more on topic today. I'd say like the father of Kerberoasting. And it's funny when I was telling Laura as I was going through, this is like one of those things that um, yeah, we've heard of and have talked about, and kind of as defenders have like, it's just like a thing that you hear and you don't really think much of. And I got to Google like just this morning, it occurred to me, I was like, I actually don't remember when you published the original research, and it's been over 10 years,
2014, so it's been ages at this
which
point.
is absolutely insane. And so like, and we were kind of chatting by way of prep, and Laura was talking to our team because I was also curious just, how often we think we still see this. And obviously there's a bunch of cases where it happens and we may not have signals, kind of
Sure.
depending what controls customer has. But, particularly in light of that, um, understanding that like we just might not always have visibility into it. And there's not much we can do to control that. But like even with what we have to assume is kind of like partial visibility at best, like we see this, call it daily, right? Like that's pretty bonkers. And then I was, kind of just picking through the Mandiant report, and like over a decade later, and this thing's still sitting like hovering near the middle of the top 10 for like initial access techniques. And so um I think, the question why it's still everywhere in 2026, I think we'll get into the details, but like just that alone is absolutely bonkers. And I'm not sure, like since you've been kind of minding this for better or for worse for many years now, I am curious, like, your overarching take on, um, how prevalent you think it is. And then obviously we'll kind of get into what it is and what to do about it. But like,
Yeah.
just the timing of this is like, is pretty fascinating.
Yeah, I mean, the interesting thing is you don't see the attack itself. You see the precursor and the after to some degree, because you see people requesting tickets, and then some point later you see someone using one of those accounts. So you kind of have to assume that A led to B, and it can be a decent period of time if the attackers are taking a decent, significant time, days, even weeks, trying to crack. It's hard to some degree to connect those dots and definitively say this is what led to this, because those service credentials, I've seen them laying around in file shares, all sorts of other places, and it could be
Mhm.
attributed to something like that as well.
And at the end of the day, right, I mean, it's a feature, right? So like the thing
Yeah,
exists, like it's not there by accident. Although maybe like, it sounds like, we're making some moves in the right direction, but at the end of the day, it is like, I mean, it's obviously necessary for systems and enterprises to function. So, I'd say for me and everyone else who probably doesn't understand, like maybe we'll just start at the beginning and then we kind of walk through a little bit more of the detail about like how and why this is still a problem and what to do about it. But like, I don't know, like give us the primer just to kind of
yeah,
understand like what this authentication protocol does, and then how Kerberoasting fits.
yeah. I mean, the if you're familiar with the mythology, the Cerberus, whatever you want to call it, it's a three-headed dog that keeps the damned in hell, and we jokingly say it's like, well, it's the three-headed dog that it keeps the people in hell, Microsoft. But there's three pieces here. I just kind of why we pick Kerberos. as the piece here. We've got our user who's trying to authenticate the system or service they're trying to authenticate to, and the third head is that trusted middle here, the domain controller, where I trust the domain controller, everybody trusts the domain controller, and all the trust goes to that. So what I do initially is just say, hey, I'm Tim. I'm going to prove who I am with my password hash. I'm not going to go into the nitty-gritty details, but then from there, I'm going to get what we call a ticket granting ticket. And I'm going to use that ticket granting ticket, as the name suggests, over and over and over again to get tickets for specific services. Now, those service tickets are unique to that one service. They will only work on that one specific service. The key piece figured out 14 years ago at this point, or whatever it was, is that service ticket is encrypted using the password hash of the target service. So what we can do is the domain controller here does not know and does not care if I have access to the target service. If it had to know that, your domain controllers would be absolutely massive. And essentially it says, hey, I'm providing you an ID. Think of it like I live in Texas, state of Texas, saying, hey, I'm going to provide you a driver's license. And now when I go to the airport, they look and they validate that driver's license, much like they would sort of a ticket granting ticket. They don't call up the state of Texas and be like, hey, is Tim real? Which gets a very deep question here. They're kind of offloading that. This is exactly what happens with Kerberos is we rely entirely on these tickets for that.
And that's so that I guess that is kind of like it's effectively like the trust is part of what makes the system extensible and flexible
Right.
and but that, yeah, I guess like that transitive or assumed trust is also like that's where we get into trouble, right?
Yeah, I mean, and the piece here, it's not that there's necessarily a fundamental flaw in Active Directory or Kerberos itself. I mean, there is to some degree. We guess we could argue that. The ticket granting ticket, you're never going to crack that. If you get the key that's to protect that, it is randomly generated. You are never going to crack that. But if you steal it, I mean, you've already compromised the domain controllers and, not a significant difference. For those service tickets, the security of that ticket is dependent on the password hash for the target service. Now, any of you who have ever worked, doing admin type stuff, we know don't touch service accounts because no one wants to generate a new resume because they took down a database server. So we just set those things up, we let them run, and until this attack came out, it didn't matter if the database service account had a really crappy password because you couldn't actually touch it. The interesting thing here is I can actually request a ticket for a service that I can't actually access the service because, again, the domain controller does not know, does not care, and says, hey, you figure it out later.
Yeah, So the act of figuring out whether you should is a separate job.
That's
right?
the service. We leave it up to the service. It
Yep.
figures it out. Like I present my driver's license, like I go to, let's say, a bar. They look at that and say, yes, you're over 21. You're not on our banned list. Cool, we're going to let you in. They don't call back to the state of Texas for that. They make the decision, much like our service does. It takes the ticket, my driver's license, makes the entirety of the decision based on that.
All right. So then now, fun part. So Kerberoasting, what is it?
Yeah, so the sort of analogy here, kind of going back to what we talked about before, is there's plenty of different. I think the best one is Movie Pass, but we haven't had Movie Pass for ages. Another one might be like Disney, where you get the magic bands, although they seem to have kind of downplayed magic bands. But let's say you're going to a fair, a theme park, or something like that. You've got to pay to sort of get into that, right? That gets us our ticket granting ticket. I am now allowed to go on rides within that specific park. Now that gets me in, but then for the specific rides, I might need additional tickets. That's sort of the split between letting me into the park, giving my ticket granting ticket. I can then get in queues, get tickets for other rides. That's going to be my service ticket. And then they decide if I'm allowed to access or not. The key here, as we kind of talked about before, is that password for that service good? It doesn't have to actually be kind of great necessarily, These days, we'll get to that in just a second here. But how do we know what a service is? So a service has what's called a service principal name, an SPN. This is the mapping between the service name, which might be like for a web server, HTTP slash web01.redsiege.com, redcanary.com, whatever, redthing.com. We just got all the reds here, right?
That's right, on
Z,
brand.
Zscaler needs some more red in there, but whatever. Um, so that's the SPN is that name and that mapping between the name and the underlying account. Because when Active Directory generates the ticket, it has to have the correct password so that the service can then decrypt that specific ticket. So big key here is that password is what we're attacking. I can request tickets for anything because I'm already inside the park. I take that and I do offline cracking. And because it's offline, there's no account lockouts. I can go as fast as my little GPUs will let me. There's no network latency issues. Like I said before, firewalls, I don't care. If I can't access the service, it doesn't matter because this is entirely an offline attack. And the DC has given me the tickets.
And particularly for a service account where, like I'm gonna make an assumption too that in more cases than we'd like, right? Like if those passwords are standard, show up in a list, I mean, the time that it takes to do that now has got to be seconds, right? Unless you've got a something like a really, really sturdy service account password, right?
Yeah, and I mean, how do you quantify that, right? That's a whole separate sort of
Yeah.
very philosophical debate here. I remember the very first one that we did, the username was, sorry, the password was the same as the username. Like it actually cracked so quickly and then gave me back the username. I thought there was something wrong with the code because I'm like, well, crap, it's just giving me back. And I ended up going through the code over and over and over again. And then I realized, like, oh, no, no, no. The password is just the username. Um, which love it like that. I do that sometimes in Microsoft Word when I spell reconnaissance correctly the first time. I don't think that I did, and I end up spending 15 minutes trying to figure out why Word didn't add the little squigglies.
Oh my
Same thing
God.
happened here.
So, all right. So then when this is happening, right? And I think, you've got again, like that principle of it being able to be offline, right? So you can work as hard or as slow or as fast as you need to as an adversary. And like maybe to the point of what we were talking about right up front, like that is like that in and of itself is a challenge. I guess, once you've got that initial foothold, you can just marinate there. This is
Yep.
not like you don't, yeah, like I mean, that core principle, you don't need like privilege escalation out of the gate. You don't need anything particularly valuable. So,
Yeah, and that's a great point. This can be done by any account, any regular user account, anything that I get access to, I can start requesting tickets. Because again, the domain controller has no idea and is not going to make the decision if I have access. It's up to the server to decide if I have access and how much access do I have. Now, there is a quick little caveat there that with these SPNs, there's two types of accounts. We have machine accounts. Well, machine accounts are randomly generated passwords and then are rotated automatically every 30 days. You are not going to crack that. It's just not feasible.
yeah,
Now, user accounts, this is something that was created by an admin. It could have a really good password where it's randomly generated. It could have like CyberArk automatically changing the password.
yeah.
But there's an opportunity that maybe an admin didn't pick a necessarily strong one. So what I want to do is target those specific types of SPNs and underlying accounts, not the machine accounts. There's also, and we'll talk about this in a little bit, the managed service accounts that we can use as a very good protection. Basically, kills Kerberoasting.
Yeah, because yeah, when you mentioned CyberArk, I would like to talk more about that later. I know we'll kind of get into mitigations because I think there's some others as well, um, but yeah, I mean, and I think we've kind of talked a little bit about this, like particularly like just the underlying notion that it's a feature. This is not some bug or thing that's there by accident. Like this is very much by design. It's very much by necessity, so that this directory service can work and remain flexible. To your point earlier, like without introducing so much upfront complexity that no one would ever be able to manage this thing,
Right.
right? So, um, And that concept that it is like it's an unprivileged account, meaning that like as an adversary, you've got, every tool in your arsenal, plus we've got initial access broke. I mean, there's kind of countless ways to get particularly an unprivileged foothold. And we can, and I guess probably technically have done a million episodes on that to date. That's most of them. Um, so talk to us like about RC4 and like what's developed there, because I know there
Yep.
have been some developments, but again, obviously like this is still very much a problem out of the gate for most orgs.
Yeah, let me give you so those tickets that we talked about, specifically the service ticket here, you might hear referred to as the TGS. I like service ticket because it's just clearer in my head versus TGS stands for ticket granting service, which is the RFC name for the whatever. Service ticket. That's the thing you send to the service, encrypted with the password hash for the target service. Now we have different ways to encrypt that. Taking a step back, there is one secret value in Active Directory. That's it. And it's the password hash. With RC4, the password hash is the key here that is used to encrypt the ticket. That's it, just the password hash. And the take a password, hash it, attempt to decrypt happens relatively quickly, very, very quickly. Now with AES 128 and 256, that is slower. Now the one secret value is still the same thing, the password hash. However, folded in with that is the realm, the domain, essentially public information, and the account, also essentially public information. So the one secret is still the hash. With AES 128 and 256, it is 350 to 1,000 times slower for cracking. So that means with an RC4, a password that I might crack in a day now takes 1 to 3 years. Which, to be honest, this is one of those situations where if you've ever heard the analogy for running from a bear, I don't have to outrun the bear, I just have to outrun the person next to me. How much time are the attackers going to spend? Are they going to spend a year, 3 years? Now, some organizations, government, who knows, maybe they will. We all know that no one's changing these passwords. Nobody's rotating them. So they are going to be good that long. Let's be honest, right? What happened in very, very recently here is Microsoft implemented a patch that says, hey, we're going to disable RC4 by default. If you want to turn it back on, let's say you have a legacy system that does not support AES 128 or 256, you have to explicitly go in there and turn that on. I mean, let's be honest, there might be an org or two who just turned it back on for everything to keep it simple.
Yep.
Hopefully they didn't. But so the RC4 is still there. It's just going to be more limited. And ideally, organizations that have specifically identified this system using RC4, ideally that allows them to review the passwords associated with those as well and make sure that they are stronger.
So, and then like like when we think about that, like, and I guess, it's mentioned here, but like, this is one of those cases where it does sound like, particularly for, I guess, our experience, like there are a good number of orgs and everyone at the high end, has got a team to manage these things and they've got a change control process. But they're, for every one of those like organizations at the high end, there's a whole bunch that just put these things up and are kind of hanging on, right? And they make changes when they have to. And I
Right.
gotta have to imagine, particularly like that this patch is breaking for an organization that might not, have the time or the rigor or the process to go through and make sure that they explicitly set a new encryption type for all these accounts to avoid this patch breaking. Like this feels like one of those awful cases where like everyone just, they're afraid to apply the patch or they avoid applying the patch because they have no idea, to your point, like no one wants to be the person that just like
Right.
torpedoes the database upon which everyone depends. And that seems super unfortunate and kind of surprising.
Yeah, I mean, it's that loss aversion, right? Like, hey, if I take something down, I'm gonna get in big trouble. If it stays up, I'm going to be fine. And it's that age-old problem with just of what's urgent. And unfortunately, the replacement for what's urgent and important in an organization is actually sort of what's visible. So if
Yeah.
it shows up as in a dashboard as being bad, cool. Now I'm being tracked. Like got KPIs, bonuses based on that. No one's looking at your service accounts to see if they're good passwords. We don't have a way to objectively quantify that. This kind of stuff isn't necessarily showing up. So we just kind of pretend that nothing necessarily bad has happened over here. So that might be why some of this is happening to some organizations.
Yeah. And I imagine for a ton of them, it's just also lack of awareness, right?
Yeah.
Like, again, like for the
Yeah. I mean, there's
definitely
a
the
lot of,
majority of organizations don't have a cybersecurity team who's researching this stuff and on top of it. And so unless it gets put in someone's face, um, it's just, I know for a fact that this is just not on a lot of people's radar, despite the fact that
yep.
like for you and I sitting here and probably most of the people here, like this is the thing that we're paying attention to from a threat intel standpoint and detection standpoint. But from
Yeah. And a lot of those medium-sized businesses, they do IT because they have to, not because they want to.
yep.
Like we did one not too terribly long ago for an insurance company, decent size, like an insurance broker type thing, not pretty decent size, and they had every vulnerability known to mankind on their DC because they turned off updates because something broke 7, 8 years ago, and they don't want to have to try to figure out how to fix it. So they just turn it off, right? And it's probably not going to be your big enterprises. They're going to have the teams and the funding to take care of some of these types of things and the requirements where it's your medium size, your mom and pop shops, they're going to get absolutely killed because that's not their job. They don't care. They have IT because they have to, not because they want to.
Yeah, and actually, I want to. We talked about this a little bit yesterday, but if we've got some time at the end for some questions, I would love to pick your brain on just like, I kind of shared. We have kind of our view of prevalence, imperfect as it is, and we kind of can read other people's reports. But I am super curious. Um, we'll kind of walk through kind of like some of these defensive measures, and then would love to just get like some of your takes from like, being in the field and kind of pressure testing this stuff. But first, yeah, take us through like let's walk through like defending because I know we've kind of already alluded
Yeah.
to like privileged access management and things like that, which I don't think really existed or were in their infancy when this was first discovered. More prevalent now, but I don't know, kind of walk us through the menu of
Sure.
options, understanding this is not all of them, but these are the big ones.
Yeah, they've got managed service accounts there, and there's two flavors. There's the local and there's the group if you've got clustered. What the short version of what this does is it turns our user style accounts into kind of like machine style accounts, meaning passwords automatically generated. You're never going to guess it. And it rotates automatically every, I forget that off the top of my head. If you hadn't asked me, regardless, it's not going to be something that you're ever going to crack. It's randomly generated. End of story, done, not going to crack this thing. Whereas that SQL Service account that we set 15 years ago that everyone was afraid to touch, it's just going to linger forever, right? So it just kills the attack. I guess the other one I didn't add here is just pick good long random passwords for these things.
Yeah.
Like that kills it too. I mean, the managed service account is kind of a fancy way to do it, but you could just pick some of those yourself. Now let's
And just
see.
to be clear, so the managed service accounts, like that's core Windows feature. That's a
Yep.
thing, like a policy you have to enable. Is it another Microsoft like service or app you have to install?
Yeah,
How
we've had managed service accounts now for, oh man, long time is the short answer. I don't know off the top of my head, but they've been around for a long time
okay.
where it's a little bit more complex of a process to set up. I'm not going to pretend it's just off the shelf, super easy, but it's definitely not complicated. And you can follow the Microsoft docs, set this kind of thing is up during a maintenance window. I mean, the crappy but also very effective answer is just change it to something good and long and random.
Yeah.
Um, that kind of has the same effect. The nice thing here is nobody knows it and it automatically rotates. Whereas the other, if there's a way to steal the hash, you kind of have persistent access. But managed service accounts, good thing here.
Love that. And then I'd say like maybe so like using a CyberArk or some other PAM, I assume falls into the same bucket, although it's, third party, maybe a little bit, some added feature sophistication, but you would kind of bucket that in the same general kind of control set, right? Which is like
Yeah, that
something
can
else.
be. This is just nice because it's already built in,
Yeah.
right? I
Free.
mean, I love CyberArk, but I would also like a Ferrari, right?
Yeah. It's a lot. And that's definitely like a management burden unto itself. Like
Yes.
you get some benefits. We've kind of talked through the encryption aspects of it already, and just like,
Yep.
obviously like the goal is just make this computationally infeasible for folks, and you can do that the dumb way, which is like, yeah, make it long, make it random. Um, Obviously using AES instead of RC4 makes a difference. Talk through like I want to talk about honey tickets a little bit, and just that concept of detection fix is like I think I and probably most people grok the concept of, like just a honey token in general, or a honeypot account. But like specifically for honey tickets, like what's that look like from an implementation standpoint? Because that kind of sounds like it's something that's like a little bit more in the guts of the directory service. So like how do
Yeah.
you implement that? Like what's the kind of level of effort there?
Well, let's take a step back, sort of a step back here. Let's talk about sort of honeypots in general. What you're commonly going to do is set these things up so that people find them, knock them over, stick their hand in them, get stuck, right? And with a lot of them, like let's say you put like a honey file, if I will, on a file share, the problem is you might have users who are going to be like, salary info, this looks fantastic, and they're going to kick that over, and you're going to have some false positives associated with that. And you're also going to know really quickly who the nosy people are. Um, However, when it comes to these tickets, no user is looking for SPNs. Like when you want to access a service, you use the specific what's called service class, the name of the service, and then the fully qualified domain name. Your computer does this automatically, but I know what service I'm going to on what computer. I'm not just trying a random array of names and service classes. I'm definitely not going to be enumerating and say, hey, give me all of the SPNs in the organization. A regular user will never, ever, ever, ever do that. They need to go to file share, cool. CIFS slash file01.redstuff.com, right?
Because they'll only be going to that in the context of a workflow or an
Yeah, exactly.
application or something. Gotcha. Okay.
You need to
Yeah.
get something done.
They're
So
going direct. Yeah.
what we do now is we set up a juicy looking service, an SPN, that doesn't point to a real service and put a good password on it. The second anyone requests a ticket for it, because a user is never ever going to request this. They just, I'm going to access the file share. Cool. I need to access that. We go to that, right? A web server. I'm going to use Kerberos to authenticate to that. They're not going to find this, for lack of a better word, non-existent service and then try to authenticate to it. So it's a really good way to be like, hey, something's juicy here. One piece is to establish the detection so that you catch the attacker. The other thing is now if the attacker is smart, they're like, uh-oh, we've got honeypots around here. And they start to slow down, and now you give yourself more time. So it's sort of a meta thing to slow the attackers down, make them second guess stuff. I personally have been in organizations as legally where I've misjudged what was a honeypot and what wasn't, and missed something juicy because everything I had to second guess myself. And I'm sure we're not getting reports from the attackers. They're doing the same thing or slowing him down. It gives us more time to find him, kick him the hell out.
Yeah. And that's like, we've been talking about deception a bunch for a whole bunch of other like unrelated reasons right now. It's just dealing with trying to figure out where, we kind of have like agents and in general, just AI kind of accelerating attack paths or making just trying a whole bunch of attack paths easier and more efficient. So it's like, it's kind of intrigued by that because it is like I do feel like deception in general for a long time was the thing that people were like, okay, cool. Once we're good at the rest of cybersecurity, then we'll do
Yeah.
this thing that sounds really fancy in the deception. When in reality, it's almost the opposite. Like this is the easiest thing to sprinkle around. Yeah, you
Yeah.
might get some false positives with the salary list file example, but you are also learning something very valuable, just maybe not about an external adversary, right? And
Yeah.
so,
Then the hard part is you've got sort of two options. You've got prevention and you've got detection. And if you want to ignore detection, your prevention has to be 100%. And it won't be, especially with all the mythos, whatever we call that thing, all those new bugs coming out. Like it's not going to be 100%. The bad guys will get in at some point, or you could have a rogue insider at some point. Cool. Now can we detect and respond quickly enough? Because the bad guys are getting faster and faster and faster. It's crazy how fast they're getting. And if any way I can make them bump into stuff or even slow themselves down, worst case, now I've got more time to limit the damage, to limit their access. Ideally, kick them out in the first place, but it might be that our best bet here is they only ransomware 10% of our organization instead of 50, 60, 70%. And to some degree, that's a win,
Yeah.
right? I
And
mean,
it's like
not
it's a
ideal,
rare
but
point of asymmetry that's kind of it's in our favor,
yeah.
right? That's yeah.
Yeah, I mean it's the age-old Home Alone, right? It's we got home field advantage. We start putting thumbtacks and grill burners on the doorknobs and stuff like that. We know where they are. We don't touch those.
I love it. Hey, I just realized the time. We've kept you a couple minutes over, so I apologize for that. But yeah, dude, this was awesome, man. I really
Yeah,
appreciate the
thank you
walkthrough
guys.
and appreciate you joining us again. I know Laura put some stuff in there. We'll obviously put these links up in YouTube and online too, because I know we've also like I think we've done, at this point hours of like I think a ton of cool educational stuff with you over the years. And so always appreciate you coming on. It is neat to hear some of the recent developments. As much as I would love to talk to you again soon, I do hope that the next time we talk, it's not it's not about this again, uh,
Right?
or at least it's some positive developments. But yeah, this is awesome. Like as always, awesome research, and we really appreciate your expertise and time here.
Absolutely. Happy to be here.